Hello, my students in grade 7. This is a new mathematics lecture. It's lecture 3, and the title of our lesson is Algebraic Expressions 2. This is part 2 of the lesson that we started last week, Algebraic Expressions 1, in which we talked about the definition of an algebraic expression. Then we talked about monomials. A monomial have a sign, a coefficient, and a variable. After that, we have seen like terms or like monomials are the terms or the monomials that have the same variables and the variables have the same exponents. Finally, we have seen how we write a monomial literally or in a simple way. The objectives of our session today, objective number 1, we will learn how to find the numerical value of an algebraic expression. Number 2, multiply two terms or two monomials. Number 3, reduce like terms or similar monomials. Number 4, reduce an algebraic expression. Number 5, perform operations on algebraic expressions. First, if we have an algebraic expression, we will learn how to find its numerical value. So objective number 1, numerical value of an algebraic expression. It's very important to know that to find the numerical value of an algebraic expression, we replace the variable or the variables in the algebraic expression by the given value of the variable or the variables. Now I will solve with you many examples. In each example, we will apply the following rule. First, I will give you the algebraic expression, which is 7 plus x. We should find the numerical value of 7 plus x for x equal 3. So the given value of the variable is 3. What we do is replace the variable or the variables in the algebraic expression by the given value. So in the algebraic expression, we have the variable x. So this variable x should be replaced by the given value 3. Simply we write 7 plus 3 because here we will replace x by 3. So 7 plus 3, it's equal to 10. So the numerical value of this algebraic expression, which is 7 plus x for x equal 3 is 10. Now another example, 10 minus y is the algebraic expression. I should find its numerical value for y equal minus 2. So y in the algebraic expression should be replaced by negative 2. Now, when I replace y by negative 2, we cannot write 10 minus 2 directly after each others, since we cannot write two signs after each others. So always in front of the variable, if there is a sign, we should replace it between parentheses. So we replace y by negative 2. I will write 10 minus. So as you can see, this y is replaced by negative 2 in between parentheses. Why? Because we cannot write a negative and a negative after each others. Now 10, negative times negative is positive 2, so 10 plus 2 is 12. 2x plus 5, we should replace x by 3. Let me remind you what we mean by 2x. 2x means 2 times x. So here when we replace x, since it is multiplied by 2, also we replace x in between parentheses. So here we multiply negative times negative, of course it's positive. So let's replace x by 3. Now I write 2 multiplied by 3 plus 5. 2 multiplied by 3 is 6. 6 plus 5, also here we multiply 2 by 3. 6 plus 5 is equal to 11. Now the algebraic expression x squared minus 3y minus 4, we should replace x by -1 and y by 2. Here, since we have two different variables, the first variable is x and the second variable is y. So let's replace x by -1 and y, we replace it by 2. Also, since x has an exponent 2, we should always replace it between parentheses. Also, y, which is 2, should be replaced between parentheses because it is multiplied by -3. So after replacing, I get -1 squared minus 3 multiplied by 2 minus 4. Now, -1 squared means -1 times -1, which is 1. And negative times positive is negative. 3 times 2 is 6, and we take the minus 4. Now 1 minus 6 is -5. -4 is equal to -9. In this algebraic expression here, this is a monomial alone in an algebraic expression. We can see that we have the variable x, the variable y, the variable z, and the variable t. So we should replace each one by its given value. X is given -2, y is given 3, z is given 5, and t is -1. Of course, we replace x, y, z, and t between parentheses since they all have exponents and they are multiplied by each others. This exercise should be practiced on draft after watching the video. Now the second objective, which is multiply two terms or two monomials. If we have two terms or two monomials multiplied by each others, to multiply two terms or two monomials, we have to apply steps. We know that each term has a sign, each term has a coefficient, and each term might have one variable or many variables, and the variable have an exponent. What are the steps to multiply monomials? First, we multiply the sign times the sign, then the coefficient times the coefficient, then the variable times the variable. If we are multiplying same variables, we keep the variable and we add their exponent. For example, if we have, I will write an example here. For example, if we have the variable x squared multiplied by the variable, for example, x to the power 5. Here, I can see that the variable here is x, the variable here is x. What the rule says, if we have the same variable, we keep it. So in my answer, I will have x, but we add exponents. What do we mean by add exponents? Here the exponent is 2, here the exponent is 5. So we say 2 plus 5, we get exponent 7. This is what we mean by this rule. Now I will apply many examples with you. Let us apply these examples, but I will erase first the example that I solved now. For example, if we are multiplying 3x squared times 7x4, here the sign is positive, the sign is positive because we know that any monomial having no sign, its sign should be positive. So positive times positive, of course, it will be positive. And then we multiply the coefficient by the coefficient. 3 times 7, it is 21. Now the variable times the variable. Here the variable is x, the variable is x. So we keep the variable x and we add the exponents 2 plus 4. Of course, it is x to the power 6. So we get 21x to the power 6. Now here I am multiplying this monomial times this monomial. If we have, for example, a monomial without a coefficient, of course, its coefficient is 1. So positive times negative will be negative. 1 times 3 gives me 3. Now the variable x multiplied by the variable x, so it will be x. And we add 2 plus 3 is 5. So x to the power 5. The variable y times the variable y is y. 3 plus 1, because any variable having no exponent, it will be 1. So 3 plus 1, I will get y to the power 4. Now the variable z times the variable z, it will be z. And 1 plus 4 is 5. So we get this answer. Now, negative times negative, of course, it's positive. 2 times 5 gives me 10. A times A, the variable will be a. Exponent 1 plus exponent 1, it is exponent 2, so a squared. B times b gives me b, and we add exponent 3 plus 4, so b to the power 7. Here we have the variable c. Here we do not have the variable c, so we keep it c squared, and this is my answer. Also, please apply this exercise on a draft to know how to follow these steps. Objective number 3, addition and subtraction of terms or monomials. Now, if we are adding or subtracting monomials, please pay attention that we can add only or subtract like terms or similar monomials. What are the steps? We add or subtract their coefficients. We keep the variable or the variables, and we keep the exponents as it is. So multiplying monomials have rules, and adding or subtracting monomials have different rules. Example, 3x plus 5x. First, before adding these or knowing if we can add these, we should see if we have like terms or similar monomials, what we studied in algebraic expression 1. Here the variable is x, the variable is x, exponent 1, exponent 1. So 3x and 5x are like terms. Add or subtract their coefficients. 3 plus 5 is 8. And we keep the variable and we keep the exponent as it is. So since they are like terms, I will get 8x. Now 7y minus 3y. Also, these are like terms. 7y and 3y are like terms. So 7 minus 3 gives me 4, and we keep the variable y. Now, negative 2x cubed minus x cubed, also here the variable is x, the variable is x, exponent 3, so we have like terms. Minus 2 minus 1 gives me minus 3, and we keep the variable x with exponent 3. 5x minus 8y. Here the variable is x, the variable is y, so these are not like terms. Because they are unlike terms, it's impossible to add different terms or unlike terms. So the answer will be 5x minus 8y. We cannot add or subtract them. Now 2x cubed y plus 5xy. Let's see if these terms are like. Here we have x, here the variable is x. Exponent 3 and exponent 1. So these two terms are not like terms. So they are unlike terms. It's impossible to add them. So my answer will stay 2x cubed y plus 5xy. Now in the last example, we have minus 4x squared y cubed z and the plus 4x squared y cubed z. Here we have x, exponent 2, exponent 2. Variable y, exponent 3, variable z and variable z, exponent 1, exponent 1. So these two terms are like terms. We can add or subtract them. Now, negative 4 and positive 4 are opposites, so it will give me 0 because the addition of any two opposites always gives me 0. Now, reducing like terms in an algebraic expression. If in an algebraic expression we have many terms or monomials and we wanted to reduce this algebraic expression, what should we do? First, we collect the like terms or the similar monomials as we used to do in algebraic expression 1, how to collect like terms, giving them the same marks. Then we add or subtract these like terms as we learned in a moment. For example, 3x squared minus 4x5 plus x cubed minus 4 plus 6x5 minus 5x squared plus 2x plus 4x squared plus 7. Here, first I should collect the like terms or the similar monomials. Here in the first monomial, I have x squared. In this monomial, minus 5, I have x squared. So this term and this term are like, I give them the same marks, which is a line. Now, here we have x5 and here we have x5. So these two are like. Also, I give them the same mark, which is a box, as we collected before. Here we have x cubed and here we have x cubed. So we give them also the same marks. Now, minus 4 and the plus 7 are numbers. We leave them as they are. We subtract or add them later in the answer. 2x or plus 2x has no like term, so it stays also as it is. Let us start. 3x squared and minus 5x squared, since they are like terms, to add or subtract them, we add or subtract the coefficient. We keep the variable with the exponent. 3 minus 5, it gives me minus 2x squared. Now minus 4x5 and the plus 6x5, also they are like terms. Minus 4 plus 6 gives me plus 2x5. Now plus x cubed plus 4x cubed gives me plus 5x cubed. Now we keep plus 2x as it is, we write it as it is. Minus 4 plus 7, of course, gives me plus 3. So this is the reduced answer. We do the same in part B. Minus 2x cubed y squared plus 5x minus 4y cubed plus 3x squared y squared plus 2x cubed y squared minus 3y cubed minus 5xy minus 6x squared y squared minus x plus 7. Of course, we should collect the like terms. X cubed y squared, here we have x cubed y squared, so we give them lines. Now 5x and minus x, we give them also the same marks. Here we have y cube and here we have y cube, we give them the same marks. Here we have x squared y squared, x squared y squared, we give them the same marks. This has no like term, we keep it as it is. We can see that minus 2x cubed y squared and the plus 2x cubed y squared are opposites, so we cancel them. Since they are opposite, they give me 0. Plus 5x and minus x. Plus 5 minus 1 gives me 4x. Minus 4y cubed and minus 3x cubed. Minus 4 and minus 3 gives me minus 7x cubed. Plus 3x squared y squared and minus 6x squared y squared gives me minus 3x squared y squared. We keep minus 5xy as it is, and we keep the plus 7 also as it is. So this is the reduced algebraic expression. Also, please apply these exercises on a draft. If you didn't apply, things of course will be harder for you. Finally, we'll talk about addition and subtraction of algebraic expressions. I will start with addition of algebraic expressions. To add two algebraic expressions together, we write the first expression and we preserve or do not change the signs of the terms of the second expression. Then we reduce the like terms. For example, I have the algebraic expression A and the algebraic expression B. We should calculate A plus B. What does the rule say? We write the first expression. So we write in place of A, we write its algebraic expression. We preserve, do not change the signs of the second algebraic expression because in front of it here we have a plus. So we write A as it is, then we write plus the algebraic expression B as it is. Now, of course, we reduce using the rules like terms. As you can see, we give them the same marks to be able to reduce them, and we get the answer. Now, Let's move to another example. Subtraction of algebraic expressions. To subtract an algebraic expression from another, we write the first expression as we did here, but we change the signs of the terms of the second expression since here we have a minus. So we write a as it is. We write minus, and we change the signs here. It was plus, it becomes minus. It was minus, it becomes plus. It is minus, it becomes plus. So we change the signs of the second algebraic expression. Of course, we reduce using like terms or similar monomials. Now, finally, I will solve with you 2a minus 3b. So the algebraic expression a will be multiplied by 2. All this algebraic expression will be multiplied by 2. So we replace the algebraic expression a between parentheses since it is multiplied by a number. Also, we replace the algebraic expression b in between parentheses since it's multiplied by -3. So we replace it between parentheses. Now, we should get rid of these parentheses. So we multiply 2 by everything inside. We multiply -3 by everything inside. After multiplying, of course, we reduce the like terms as we used to do before. Also, please, guys, these exercises are very important to apply them before we join our Zoom session in our classes. This is not a hard lesson. It has many things and new things in it. There are many rules that you can see here regarding each objective. There are steps and rules that should be applied. Please, as I always say, watch the video well, understand every single information in it, write notes on your math copybooks, apply the solved exercises in every slide we have. And until we meet on Zoom, I hope you all keep safe. Thank you and see you all.